Hey guys, welcome to day 12. It's Happy Monday. We're going to be continuing our discussion of multiplying polynomials, as well as looking at some shortcuts to doing it a little faster. And keep in mind, because we're discussing how to multiply polynomials, we're also discussing how to factor polynomials. Because remember, those two concepts are antithetical. They are opposites of each other. If you can see how to multiply correctly, it can lead to strategies that tell you how to factor correctly, and different approaches you can use. And so keep that in mind as we go through today, and we'll look today at some basic multiplication problems. Let's get started. Alright, first of all, for today, we're going to have first a little review from last time. Last time we discussed kind of a little bit about foiling, which is a pretty important little concept, because if you're talking about how to multiply two things, this is one of the best ways to do it. 2x minus 10 times 3x plus 3. So we have the first little example. Now, in order to multiply these, we talked about a process referred to as FOIL. FOIL is an acronym, meaning that each letter in its name stands for something. In this case, it stands for a specific operation. F stands for first, meaning to take the first in each set of parentheses and multiply them together. O stands for outer, which tells you to multiply the outer two together. I stands for inner, and L stands for last. And so FOIL is simply an acronym that's designed to help remind you of what 4 different operations you have to do. However, FOIL is not the only way. I rarely use FOIL. I prefer the distributive property. Now, the way the distributive property works is you take your two parentheses, and you can do this in either direction. What you do is you take this first parentheses and break it apart into two separate multiplication problems. 2x times the separate parentheses, and the negative 10 with the parentheses. This is a version of the distributive property, where I've taken my first one and distributed it to each particular part of the second parentheses. So 2x is distributed to the second parentheses, and the negative 10 is distributed to the second set of parentheses. From here, you then just do the actual operation of multiplying to these two. So we distribute a second time, 2x times 3x plus 3, which would give us 6x squared plus 6x. And then you take the second one times each part of the parentheses. Remember to do it to both, and keep track of your signs as you go. Negative 10 times positive 3x would be negative 30x. Negative 10 times positive 3 would be negative 30. Make sure when you finish to write your product as a simplified polynomial. So we'd have 6x squared. 6x and negative 30x would become negative 24x. Remember, because they have the same variable, we can put them together, and we put them together by a strange version of factoring. And then negative 30, of course. So what this does is it allows us to take our function, which is written as a multiplication problem, and rewrite it as an addition or subtraction problem. Notice we have reduced the complexity, which is the goal of a lot of mathematics, is to reduce complexity. We took something that was being multiplied, which is a complex process, changed it to something being added or subtracted, which is an easier process. So this is last time's material, being able to multiply a particular polynomial consisting of binomials in this case, where we have two terms here, two terms there, being multiplied to each other. If you happen to have more than that number of terms, so for example, if I have this equation, x squared minus 4x plus 3 times x, now let's go with 3x, minus 5. If we wish to multiply these two, the big thing I want to notice is that FOIL doesn't really work. The reason being is because if I do first times first, outer times outer, inner times inner, and last times last, I skip some terms. They're not all being multiplied through. And so that's why I recommend very strongly to use instead the distributive property, where I take x squared times the parentheses. X squared times 3x minus 5. I take negative 4x times 3x minus 5. And I take positive 3 times 3x minus 5. This process always works no matter how many terms you have. FOIL works specifically with these binomials because it tells you exactly which pieces to do, but the distributive property works much better whenever you have something that is not quite fitting in that form. And so from here we can simplify again. X squared times 3x minus 5 would be 3x cubed minus 5x squared. Negative 4x times 3x minus 5 would be negative 12x squared plus 20x. Again, keep track of your signs as you go. It'll help prevent a lot of mistakes. 3 times 3x minus 5 would become 9x minus 15. And then again, we want to make sure to simplify anything that we can. We have a 3x cubed is the only cubed. We have these x squareds, which would make a total of negative 17x squared. We have positive 20 and positive 9 for positive 29x, and then negative 15. So taking these steps and these processes, distributive property is the best one because it works in more circumstances, but FOIL is easier when it works. Well, this is great. This offers a great ability to be able to take a function and multiply it through and be able to get to solutions. But there are some specific ones that work faster and easier. Let's take a look now at today's material. In this case, we're going to be looking at perfect squares first. Perfect squares indicate you have a polynomial, so like x plus 5, and you are squaring it. Now first of all, by definition, what this means is you take x plus 5, and squaring just means to multiply it by itself. So it would be x plus 5 times x plus 5. You may always take this step because it is always true. So if you have something squared, you may always break it down into two components being multiplied. As long as they're the same components, x plus 5 becomes x plus 5 times x plus 5. This is always true. This is always the case. And once it's here, we can now use either FOIL or the distributive process to be able to get to a solution, which I'm going to do now. In this case, I'm going to use the distributive process. So I take x times x plus 5 and 5 times x plus 5. From here, we simplify. X times x plus 5 would become x squared plus 5x. 5 times x plus 5 would become 5x plus 25. And then we simplify, becoming x squared plus 10x plus 25. Now, why would we talk about perfect squares in particular? Because it turns out there's a shortcut to finding a solution. And what this statement says is, if you have a perfect square, like x plus a squared, one of the ways you can simplify it is by using the formula x squared plus 2ax plus a squared. This is one of our first big formulas. We'll talk about a couple of them over the summer. This is one of those that is very, very helpful because if you understand it, it can make this process a lot faster to do. Take a look at this equation, how many steps it took us to do it using the distributive method. And while it is a little bit shorter with FOIL, it's not much. But let's do this exact same problem now using the formula instead. So my original equation is x plus 5 squared. So in this case, my a is 5. What I can do is take this equation and just do a simple substitution, meaning everywhere there is a, we replace it with 5. So x squared stays x squared, 2, a is 5x, plus 5 squared. And from here you can clearly see that we get x squared, 2 times 5 is 10x, and then 5 squared is 25. Notice how much faster and easier we were able to get to this solution. You know, this only took one major step, just plugging everything in and then simplifying. Now, it is important to note that this is not the only way we can use this formula. Example, if it's more complicated, like let's say, instead of having just x, let's say it's another variable, like say b plus a. Well, it just becomes b squared plus 2ab plus a squared. And you can do this in any order you want, which means that even more complicated perfect squares can be done in this form. Take a look. If I wanted to do something like let's say 3x minus 8 squared. Well, obviously, I could always rewrite it. That's always true, right? So I could rewrite it like this and then start doing the distributive property. But I'm going to attempt to do this problem with the shorter method. The shorter method, its goal is to be better, it's to be faster, it's to be easier. And what's it say? We take the first term, we square that first term. So if my first term here is 3x, my second term here is negative 8. We're going to do a simple substitution. We're going to take this formula, and everywhere there's a b, we're going to replace it with 3x. Everywhere there's an a, we're going to replace it with negative 8 and see what happens. So here's my formula. Let's plug it in. 3x squared plus 2 times negative 8 times 3x plus negative 8 squared. Now, obviously we're going to have to simplify some things, so in this case let's make sure we know our algebraic properties well. When we square, we could take that square and apply it to both of them. So 3 squared would become 9, x squared would become x squared. 2 times negative 8 times 3 would be our numbers. 2 times negative 8 would be negative 16. Times 3 would be negative 54. And x, of course, is just x. Negative 8 squared. Negative 8 times negative 8. Negative times negative would make that positive. 8 squared is 64. So just to illustrate, we were able to do this successfully in one complicated step, right? We take this function and we just have to square it, multiply these two things, square that piece. Now, there are places where mistakes are common, right? If we square this wrong, we're going to get a wrong answer. If we multiply this wrong, we're going to get a wrong answer. If we square this wrong, we're going to get a wrong answer. And so there are some things that you have to pay very close attention to, but notice how it's able to do this operation in one clean step. Compare that instead, if all I have left is this space, I can't even do this problem using the old methods. If I do 3x minus 8 times 3x minus 8, I'm going to quickly run out of room, and yet I'm still not even going to be done. I take 3x times 3x minus 8, I take negative 8 times 3x minus 8, I then distribute. 3x times 3x would be 9x squared. 3x times negative 8 would be negative 24x. Negative 8 times 3x would be negative 24x. See why it's so important to double check? Negative 8 times negative 8 would become positive 64. I made a mistake up here. Like I said, the most common things to happen is you just make simple mistakes, like 2 times 8 times 3 is not 40. It is not 54, it's 48. And so this formula is nice because it can be faster, but because it's so nice, you're more likely to see mistakes. Because you're more likely to rush it. You're more likely to take it too fast, like do simple things wrong. And so we should end up with, again, 9x squared minus 48x plus 64. And so, yeah, we get the same answer, but this is a little bit longer process. If your goal is speed, this one will do it faster. It just has some difficult steps to it. If your goal is to get it right, this one will get it right. It just takes longer. And so you can see that this perfect square formula is a very specific scenario that allows you to multiply functions just a little bit faster so we can see if we can get to the right solutions. Let's try this one. This time I'm only going to do it by the formula. We have 4x minus 1 squared. We'll do one more afterwards, where it'll be 2/3 x minus 6. This works with any particular function, so I can do fractional values, I can do anything. As long as it's a square, this function will work. And so I usually write out my perfect square formula for, like, if I'm taking a quiz over this at some point in time, I usually will write out my perfect square formula, which I like putting alphabetically, but it doesn't matter. This becomes a squared plus 2ab plus b squared. It's all the same thing. And so all I have to do is figure out, okay, what's my a? My a in this case would be 4x. What's my b? My b in this case would be negative 1. And I just got to plug into this formula a and b. So 4x minus 1 squared is equivalent to 4x squared plus 2 times 4x times negative 1 plus negative 1 squared. You notice I'm putting each of these in parentheses because I don't want to make a mistake by somehow moving a negative when I shouldn't move it or something else. So I put them in parentheses to make it clear that this square is being applied to both the negative and the 1. This multiplication is being applied to 2, the 4x, and the negative 1. This square is being applied to both the 4 and the x. From here, just make sure to simplify correctly. 4 squared is 16, x squared is x squared. 2 times 4 times negative 1, okay. 2 times 4 is 8, times negative 1 would be negative 8. X is just x. Negative 1 squared, negative 1 times negative 1, a negative times a negative would make it positive. 1 times 1 would be 1. And so again, it can take this process and make it much faster by making the steps just a little more complicated. You have to plug it into a formula. And the thing about this shortcut is you have to know this formula to make it work. Now, you could always go back and do it the old way. There's no rule that says you can't. In fact, when I do a quiz over this material, you can use this technique if you want. But if you find that your homework is taking a long time, if you find that you're not able to get the solutions in less than a minute, maybe you want to learn this technique because it does do it faster. It's just you have to be willing to do it. Let's look at this last one here. If you look at this last one, in this case, my a would be 2/3 x. My b would be negative 6. So now when I do this problem, I just have to plug in. So 2/3 x minus 6 squared is, I would do 2/3 x squared plus 2 times 2/3 x times negative 6 plus negative 6 squared. Okay, let's do this. 2/3 x squared. So I would distribute the square to both pieces. 2/3 squared would become 4/9. X squared would become x squared. 2 times 2/3 times negative 6. 2/3 times negative 6 would become negative 4. Times 2 would become negative 8x. And then negative 6 squared, negative times negative would make it positive. 6 times 6 is 36. And again, I could always go back and do it the other way if I chose to. I'm not going to be standing over your shoulder demanding you do it one way or the other. I'm not even going to grade you wrong if you do it the other way. I want you to learn this technique, but it's not required to do math. It just makes your math easier. Now, that being said, this is one type of multiplication that does get faster. And keep in mind, it is possible, as a third example, and our final one before I move on, to see it written the other way. And see it written the other way and be like, oh, I guess I'm going to FOIL this. But in fact, we could just think of this as 4 plus 2x squared and then use our shortcut. Because it works both ways, we can take these and put them back as a perfect square and then use our formula. Or we could take our perfect square and split them apart and use other techniques like FOIL and distributive property. Any of these work. This just happens to make the math faster and easier if we're willing to do it. So there it is. That's our first part of our homework tonight. This is referred to again as the perfect square formula. And there's two different versions of it. There's the x plus a formula, which is fine. It works pretty well. The other version is the a plus b formula. It works really well too. I usually focus on this version because if I get something like a 4x minus 1, well, then I get confused about where my x is and where my a is and where my b is. And so this formula works really well because in this case, a can be anything including 4x. B can be anything including negative 1. And so we can do our substitutions and get to our solutions just a little bit faster than we would before. So, today, perfect square formula. Perfect. Good start. Let's talk about the second thing today. The second part of today is called the difference of squares shortcut, or often just difference of squares. It's called difference of squares because of where it ends, not where it begins. So let's take a look at this multiplication problem. X plus 3 times x minus 3. You might notice that in this problem that these two are the same exact parentheses except one sign change. These are the exact same things except there is one sign change. X is positive, 3 is positive, negative 3. There is one sign change between these two. So two of the pieces are the same, one of the signs is different. What this tells me is that when I FOIL this through, something unique is going to happen. So let's actually multiply this through. X plus 3 times x minus 3. Let's watch what happens when I actually distribute and try to FOIL. So I'm going to FOIL this time. So first would be x squared. Outer would be negative 3x. Inner would be positive 3x. And last would be negative 9. Watch what happens here in the middle when I simplify this. X squared stays x squared. We have a negative 3x and a positive 3x. Negative 3x's and positive 3x's together would cancel, leaving 0 x's here in the middle, which means I'm basically going to drop them. And then we have just plus 9. If you don't remember how to do that, negative 3x plus 3x, you could, of course, factor out the x. So we get negative 3 plus 3 times x. And negative 3 plus 3 is 0, and 0 times x is going to be 0. It doesn't do anything. So these middle two pieces went away, and I want you to notice one more thing of what the result looked like. So my original one was x and x. My result has x to start it with. My last ones are 3 and 3, and this has a 9 to finish with. You should notice that in general, if you have a plus b times a minus b, if it matches this specific form, the shortcut is it's a squared minus b squared. This is always true, and it works both ways. So if we were asked to factor something, if we were given a squared minus b squared, we could write it as a plus b times a minus b. In other words, this is yet another shortcut that works in specific scenarios. So we have things like FOIL that works in a specific scenario. We have the perfect square formula that again works in a specific scenario. We have the difference of squares. Again, these ones are all very specific. They work only if they're binomials, only if they are a squared binomial, only if they are a binomial that fits the specific description. Like these are very specific. Or you could use the distributive property, where this one works always. And you can always fall back on this. Like I could have done this with the distributive property instead, and I will get this exact same solution. But again, this formula just allows me a faster way to get to solutions if I'm willing to take that path. Take a look at the next one. We have 9x plus 4 times 9x minus 4. So once again, it matches the specific description. We have two terms being added, and then those same two terms being subtracted. So how do I do this? Well, 9x plus 4 times 9x minus 4. In this case, my a would be 9x. My b would be 4. Okay, let's plug them in. We'd get a squared, which would be 9x squared, minus b squared, which would be 4 squared. And notice, if we choose negative 4 instead of positive 4, the square is going to fix that. It doesn't matter which one you choose, as long as it's in parentheses, it's going to fix itself. I'll show what that looks like here in a second. But when we simplify, you take 9 squared is 81, x squared is x squared, minus 4 squared is 16. Much faster way of doing it. Again, I could do it with the distributive property, but it's going to take a lot longer. I would do 9x times 9x minus 4, and then I would do 4 times 9x minus 4. I could then distribute. 9x times 9x would become 81x squared. 9x times negative 4 would become negative 36x. 4 times 9x would become positive 36x. 4 times negative 4 would become negative 16. And then I combine like terms. You can see how in the middle these two are going to cancel. And we end up with 81x squared minus 16. We get the same result no matter which way we do it. And if we use FOIL, we get the same result. Like, it doesn't matter which way you do it, it's just this one's a little faster. It just is. And if you can see it right away and get that solution, this can take a problem and do it in, 10 seconds. This can take a problem and do it in 30 seconds. What's the big difference? Well, if I give you 20 problems tonight, do you want to spend 3 minutes doing your homework? Or do you want to spend 9 minutes doing your homework? Let's say I gave you 100 problems. Okay? Do you want to take, an hour to do them or 3 hours to do them? It's a big difference, especially when you're looking at something that can be done so simply. So, there's that piece. I'll do one more example just to kind of showcase how this works. But this always does have this property. And so, as long as you can figure out A and B, plugging into the formula is relatively simple. So I'll keep that formula up there. Let's do one more example. The example I want to do now is 2x minus 7 times 2x plus 7. Okay, so just like before, in this case my A is 2x, my B, I can choose it to be positive 7 or negative 7. It really isn't going to matter, because when I plug into the formula, I have a squared, which would be 2x squared, minus b squared, which is negative 7 squared. Notice that in my formula, there is a subtraction sign between them, and so I can't confuse the subtraction in the problem with the subtraction in the formula. So this becomes 2 squared is 4, x squared is x squared, minus, it's negative 7 times negative 7 will become positive 49, but it's already being subtracted, so it's negative 49. Don't confuse. In this case, I know this seems strange, but there are actually 3 negatives. If we were to write this formula out, which I would not recommend doing, but if you were, this is 2x times 2x minus negative 7 times negative 7. Right? Because we can always convert squares into their proper form. 2x times 2x is 4x squared. Negative times negative 7 would become positive 7. Times negative 7 would become negative 49. And so it will get us back to here. Again, this is always an option, no matter where you're at in the problem. It's just, you should be going to here. And so, hopefully you take the easier path and use the positive 7, because it makes the math a lot easier to do. But if you happen to choose the wrong one, as long as you're putting it in parentheses and squaring properly, it'll fix itself, which is pretty neat. To finish with, all we have are a couple of the problems we talked about where it's multiplication. In total, that's all you have tonight, is just multiplying. We're going to talk some more about factoring and factoring techniques next time. That'll be our goal, and we're going to use that to segue into the graphing portion. Finally, I know everybody is looking forward to that part, but it's my favorite part particularly. So your homework tonight will be 20 problems. If you learn the shortcuts, you can do them in under 10 minutes easily. If you don't, expect this homework to take some time. I'm not going to tell you how much because I don't know your ability, but it will take some time. So, there you have it. That'll be it for today, and I'll see you guys tomorrow on Tuesday.